Welcome to Embedded Edge with Nitin, a podcast that brings to life the stories behind today's embedded systems, technologies, and products. It's the show where you'll hear from both engineers and executives on some of the most topical news and most pressing challenges in the world of embedded system design. Here's your host, Nitin Dahad.
Well, hello, this is Nitin Dahad, and welcome to this latest edition of Embedded Edge. Today, we're talking to Declan Starr, who's the Director of Marketing for Smart Home Applications at Infineon Technologies. And we're going to be talking about occupancy sensing and the intelligence behind the smart home. Declan, hello, how are you?
Hey, Nitin, how are you doing?
I'm good. Well, thanks for joining me on this podcast. We've got an interesting topic here on occupancy sensing. And before we go into that, Declan, just give me a bit of your background, and then we'll go into what's driving the need for occupancy sensing.
Yeah. As I said, thanks for having me again on this podcast. I'm a big fan. I'm a director of applications marketing for the smart home within Infineon. So applications marketing is like Infineon's methodology to move away from product selling into more application and system level selling.
Okay, and so you've been with Infineon and like in this area for a long time, I guess.
Yes, I came into Infineon via their Cypress acquisition back in 2020.
That's right. Yes. So you've got quite a bit of experience, is what my point was. So that's good. So let's talk about the topic, occupancy sensing. Why do you need occupancy sensing? And I guess it's quite relevant for smart homes and everything. And I've been hearing about it for a while. We've been writing about it, but let's get it from you, the expert.
Yeah, I think up to this point, the smart home has been more the connected home. You had a lot of disparate connected devices. And now I think with the advent of Matter, we can move from the connected home like truly into the smart home, where all of these smart home devices can now interoperate and communicate with each other. And I really think what's driving the need for occupancy sensing then in the smart home is, hey, people just expect there's a growing demand for more intelligent homes that basically anticipates their needs. And it's up to us as device makers and our customers basically to supply the needs. And then also, more and more devices are in the home. So there's now more and more regulation around stuff like standby power. So, that's also something where occupancy sensing can help. And then, of course, the big buzzword of the day is AI. And I think that there's technology advances and challenges that comes with new devices. And occupancy sensing also plays a role to help there.
Interesting. I mean, you threw a term in there which maybe just got lost in the noise. There was Matter. So I think just for the benefit of the audience, we're talking about this standard at the application layer for interconnecting different devices around the home. Is that right?
That is correct. Yeah. Before, Matter is trying to solve the problem that any smart home device that you buy off the shelf can be ecosystem agnostic. I mean, it can work if you're an IKEA ecosystem person, it works on that ecosystem. If you're an Apple HomeKit person, it works on that ecosystem. So just guaranteeing that any smart home device that you buy off the shelf that has the Matter certified label, that it will interoperate with every other Matter certified device.
Okay, brilliant, because it is something that's been now in the industry sort of developing over the last 2 to 3 years. So I think that's quite good. Let's talk a little bit about some of the examples in the smart home where we're using occupancy sensing, or whether it would be useful in more intelligent homes.
Yeah, I think one use case that the majority of people I think are familiar with is the smart thermostat. The likes of Nest about 10 years ago brought out a smart thermostat, and it really changed the landscape. It was able to detect when people were actually present in the home. So rather than doing rigid timing of wake up at 6 a.m., set the timer, put it on again in the evening, this was now intelligent. It could learn what your pattern was, and it would adapt accordingly. And then also there's smart lighting. What's the point of having a room lit if there's nobody there? And HVAC is one where we see a huge benefit in occupancy sensing, because again, what's the point trying to heat and cool a space when there's nobody physically present? And then my last example is like security cameras. They started off having like a PIR, so a very kind of almost dumb occupancy sensing approach, and now that's being replaced with radar sensing for advanced presence and occupancy detection.
Well, I've been an early adopter on some technologies, and especially the security cameras. And when a bit of wind is blowing a tree branch or something like that, this is obviously external, but it's taking that internally as well, where it just triggers on anything, and that's kind of annoying. Inside, for example, if something through the window moves, inside the camera will alert. So it's important to then add a layer of intelligence, I guess.
Yeah, absolutely. I mean, the business model around security cameras, has kind of migrated to be around storage. So you get, a certain amount of storage. And with this kind of non-intelligent approach, as you said, the wind, wind blowing your neighbor's tree, and it just happens to be in line of sight of your camera, suddenly you end up with your storage being full by just recording those events. Yeah. Whereas really people want it to be intelligent, want to have that alert when it's actually, something of value, somebody trying to break into your home, or, something that's way more useful information.
Well, you also mentioned, in the room, sort of lighting and HVAC. Over the years, we've seen it a lot in sort of commercial buildings, offices, and whatever, where the lights come on when you come in, and the heating will come on or off. But I think what we're talking about now is bringing this into the smart home.
Yeah, absolutely correct. I mean, we're seeing advanced use cases where people want, like first responders, they want to be able to understand, hey, where are the people in this home? If there's a fire, if there's an event, an emergency event, they want to be able to detect, where are the people? Are they in the bedrooms? Are they in the living room? And this, with these advanced occupancy sensing solutions, this now becomes possible.
Yeah, and that sort of leads us into the next topic. We're going to be talking about the benefits of occupancy sensing, and we've talked about some of those. But the things like energy efficiency and cost savings, user experience, home security and safety. And do you want to just maybe sort of give us some thoughts on those?
Yeah, I think some of the key benefits, as you correctly pointed out, Nitin, are for occupancy sensing are energy efficiency and cost savings, right? People want precision control. As I said, like the thermostat example, we're moving away from basic timers. We want, if you have occupancy sensors, then naturally lighting and HVAC systems, they only operate when the space is in use. So overall, this reduces the energy consumption. And then we are seeing, even in like the home appliance space, we're seeing they're starting to get more and more rigid about what we call standby power consumption. Something like 5 to 10% of the energy consumption in the home is from appliances that are in a standby mode. So you can also use occupancy sensing there. So it just powers down the appliance until somebody is standing in front of it, and then so that has a dramatic decrease in energy drains in the home. And then, of course, the last point on energy efficiency is predictive. It becomes, they can learn your routine over time, and then they can make predictive energy adjustments. And we're moving to kind of time of use for utility supply, and you can optimize your usage around when it's more cost effective for you to use that appliance.
Just to stop on that point, the predictive. Now, you mentioned AI earlier, and that's kind of where it comes into sort of having a bit of intelligence in the sensor or on the actual system that's in the home that can learn these things. Is that right?
Yeah, very true. I mean, we're talking a lot about the sensors, but of course you need something behind it to actuate it. You need, a lot of this cloud-based stuff today, or AI, based stuff today is in the cloud. and will eventually move to the edge. But it's a combination of the sensors plus, some actuation and connectivity solutions to get it to the cloud and then ultimately infer it and get it to the edge.
Yeah, I mean, I think the precursor of that was things like your sort of speaking devices like Alexa, Siri, Google, all that. So I guess this is now the next step in that in terms of that advanced smart home.
Yeah, absolutely correct. I mean, we have seen how fast and how quickly these voice assistants have developed, and how how intuitive it is to speak and to use the voice control to operate the home. And then, of course, the next iteration of AI ML will mean that occupancy sensing will become very, very intelligent and very intuitive.
Yeah, one of the things that sort of always amuses me is when I'm sitting in a room and the sensor basically goes off when I'm sitting still for a while. Maybe I've been drinking my whiskey and I'm just sitting there for a while or something like that, and then the light just goes off. So I think in the next sort of benefit is the enhanced user experience, I guess, determining presence versus motion, isn't it?
Correct. Yeah, I think we've all had that experience where you're sitting still reading a book or doing whatever you're doing, and next thing you have to do some sort of yoga move, moving, flashing your hands to get the lights to turn back on. So again, with more advanced sensors like a radar sensor, for an example, it can detect that you're there even if you're not moving. I mean, these sensors are precise down to millimeters of accuracy, right? So. And then also it allows you, with more advanced use cases, it allows you to personalize the environment. It knows, it can distinguish you from your partner. It can distinguish you from your kids. So, it can adapt the music, you can adapt the mood to end up with your custom scenario in the home. And then, of course, as I said, we have the voice to go hands-free, but now you also have automation and gesture control, which is possible. So you can intuitively control the home, without having to physically touch, your plugs and switches.
I mean, we're going to talk about technology later, but just on that presence detection, for example, I guess it'll be things like heat sensors or radar or those kind of technologies that sort of measure that somebody in the room. Is that right?
Yeah, it's really amazing. Once you put a sensor, that sensor could be a CO2 sensor, it could be a radar sensor, it could be a microphone. Once that sensor is in situ in place, you start to take the data, and you start to see the patterns of you say, how can even something as simple as a CO2 sensor, you can see when somebody's in the room, that's CO2 sense the levels increase. So it's really, there's many different solutions to go and address, from completely non-invasive all the way up to having cameras, but it's really an emerging space, and it's not a one size fits all solution.
Exactly. Now, we talked about energy efficiency and cost savings. We've talked about user experience and comfort. What about home security and safety? How does that help?
Yeah, I mean, there's been a lot of stories in the press where the celebrities or sports stars are getting their homes broken into because people can see, they're not at home. So it's possible with these occupancy sensing solutions is to have intelligent deterrence, right? You could set up programs that it knows you're not there, and it says, hey, it can turn on the lights or make it look like it's like the classic scene from Home Alone where
exactly.
The kid is faking that there's people in the home, right? This is all possible. And of course, with security and safety goes hand in hand with what we talked about emergency response. You have very precise information on where the people are in the home, which is very, very useful for your first responders to evacuate people quickly from the home.
And I don't know if people relate to this, but maybe the older people might. There's two movies. There's one is obviously Home Alone, which is a sort of classic. But then there's also Ferris Bueller's Day Off, where he sort of simulates his presence in the home. And I'm not sure if you've seen that, but it's quite funny.
Oh, yeah.
And these are the kind of things that make that more advanced.
Oh, for sure.
Anyway, well, let's talk a little bit about the new technology innovation and standards. So, tell us a little bit about the technologies involved in occupancy sensing for the smart home.
Yeah, there are many different technologies. We kind of here at Infineon, we break it into like kind of three buckets. We call it, like close end sensing, which is kind of less than a meter. And in that we use capstance, like capacitive touch and sensing technology. So there's proximity mode that we can use. Also, there's acoustic sensors. So think about very high fidelity microphones that can listen. Then there's like near field. What we call near field is kind of less than 5 meters. And for this technology, we have solutions around 60 gig radar.
Yeah.
There's also, there's also, it's possible to detect, there's so many devices, wireless devices in the home, that it's also possible to use Bluetooth channel sounding to go figure out, where somebody is. And in the same way you can use Bluetooth, you can also use Wi-Fi. You can use Wi-Fi channel state interference. So just you walking around your home, you're affecting that Wi-Fi signal. So it's possible to kind of reverse engineer that to say, okay, to tell me, okay, I can see Nitin is walking from his kitchen to the dining room.
Yeah.
And another near field one that's kind of emerging is ultra wideband. We've seen some of the major smart home suppliers recently in the last few years have added ultra wideband to their smartphones. And this is kind of driven by some of these, air tags, smart tags, these kind of find my ecosystem. And that's also possible and from the near field. And then from like far field sensing, then it's like 5 meters and beyond. So we're looking at technologies like 24 gig radar, just based on the physics. It can reach further, see further. And then as part of this, the new advancements in Wi-Fi 7 and Wi-Fi 8, we're seeing what's called 11AZ, which is basically the next advancement of this kind of channel state interference. So like basically lots of new technologies and standards coming. And then you layer in AI and ML on top of that you'll see the use cases, of course, will start off, you'll basically the very, methodology of AI ML is you have the sensors, you take the data, then you you can see the patterns are pattern matching in the cloud. And then basically you can infer it and eventually, push it down to the edge.
You mentioned one thing, the microphone, and it's something Infineon has been doing for a while. And actually, people won't think of a microphone as a sensor, but it does actually help in a lot of areas, isn't it? Yeah,
I mean, we there's a lot of people that are for occupancy sensing in the home, they just don't want they want a very non-invasive solution. They don't want, even if you tell them, hey, this is not a camera, it's a radar sensor. People want very simple. If they just want to know something is there, then a simple microphone listening or kind of echolocating, sending out a ping and getting a bounce back off somebody can be a very simple, elegant solution for very basic occupancy sensing.
Like a Doppler measurement. Yeah, it's interesting. But also, these technologies also are useful for things. I mean, we're going to talk about examples, but, old people living alone, it's kind of that aged living, smart living, smart home kind of, it aids that, doesn't it?
Yeah, absolutely. If you, as you said, if you have a parent or an aged loved one living alone, instead of you picking up the phone, 3 times a day to check in and annoy them, if you can see the pattern, you can see, hey, okay, I saw mom woke up between her normal time between 7 and 8 a.m. She made her way from her bedroom to the bathroom. I can see she's in the she's moved into the kitchen, probably having breakfast. It's possible for you to kind of observe that from afar without her, without you having to bother her. And it gives you peace of mind that everything is okay. So there's, I think and it's privacy friendly, right? You're not bugging her. There's no camera on her. She feels like, she's under the microscope.
Yeah. Let's talk about some of the real world examples that you've seen or been working on with smart home companies in occupancy sensing. Give me 2 or 3 examples.
Yeah, I think as ever, adoption is always driven by a customer benefit, and one of the key ones we touched on a little bit earlier was with LG is around HVAC, heating, ventilation, and air conditioning, and basically. This is one of the first, it's what, if you look up, we talked about Matter earlier, if you look up Matter certified products, you'll see a lot of is around HVAC. Why? Because, rather than you're living somewhere in a warm climate or a cold climate and you have to keep the house, warm all day, how much more efficient is it that when you leave the office or you're on your way home, that you can send a message, or hopefully with AI ML, it'll look at your calendar and say, okay, I expect Nitin to be home in the next 45 minutes. I'm going to start preheating or pre-cooling the home, right? So it's really energy efficient, energy aware, and as ever, very, well adopted because it saves the end customer real money.
And then I think you talked about things like Wi-Fi security cameras as well, and replacing PIR sensors.
Yeah,
or
another
them.
really interesting use case is around smart TVs. So we've worked with some of the leading smart TV companies around figuring out, okay, who's watching, who's sitting in front of me, who's watching the TV, and then with these smart TVs, they can use that data. They can use figure out is one person directly in front of me on the couch, or it's multiple people in the family around, and they can basically beamform. They can form the sound to more direct it towards you if you're the only person sitting on the couch, or if there's multiple people. So there's some really innovative. Use cases for occupancy sensing, and as I said, some will save you money, but some are just more about convenience and experience.
Exactly. You talked about all the different technologies and how just tell us a little bit about how Infineon is helping those smart home device makers to drive innovation. And you talked about close in, near field, far field, and you talked about some of the technologies. But is there anything else you wanted to add to that?
Yeah, I mean, basically, we're seeing the emergence of all of these different occupancy sensing use cases and scenarios and situations. And as I said, there's no one size fits all, right? There's no one clear solution. I think the solutions will the problems will find the right solution in terms of cost, in terms of convenience, in terms of privacy and all that stuff. So, but what we're trying to do at Infineon is, hey, to add Wi-Fi sensing to your product, you don't need to become a Wi-Fi expert, right? So the kind of onus is on us to develop like intelligent and integrated solutions. And that's the sensor with the right amount of MCU, with the right form of connectivity to get it to the cloud or whatever. So really, we're all about trying to create, end-to-end solutions that can be easily where our customer becomes the integrator of that solution into their end product.
And there's more to the enablement, and I think we talked about it on another podcast with Infineon. But around things like the code, the models, the toolbox, the evaluation kit. Is that right?
Yeah, correct. I mean, when I say deliver an integrated solution, I'm not just talking about the hardware and a demo, and it's the hardware with the software and with the firmware, with a model, let's take radar as an example, with a model to get you started. Maybe this is PIR replacement, which is quite common. So you get a model that basically you can use out of the box, but then you can also, our customers are the security camera experts. They can use our model, or they can build their own, or they can bring their own. And that's totally, all of those three distinct flows are all catered for in our backend, in our IDE system.
Okay, well, I mean, we've had a really sort of fascinating conversation. I mean, what sort of I get from this is, there's no one technology. People are looking for, sort of more user convenience and also energy savings and security and all that kind of stuff. But what would be your top three takeaways for the embedded audience here?
Yeah, I think my takeaways would be, smart homes, as I said, they're finally moving from being a connected home to have the ability to being a smart home. They're becoming more intelligent. They have the ability to be more intuitive, because people want their home, their needs to be anticipated. So I think we're now moving into a more dynamic, learning driven environment versus kind of rigid scheduling that we've had in the past. As I said, we're working with some of the big OEMs to go meet these needs, whether it's with radar sensing for HVAC, whether it's with capacitive sensing for some close-in lighting, or whether it's Wi-Fi channel sounding for basic presence around the home. And for us, the goal is to deliver, as I said, integrated solutions, hardware, software, firmware, to take the burden off our customers to become the next 60 gig radar expert, or the next Wi-Fi 11AZ expert, so that they can just integrate these solutions into their end products in a timely fashion without a huge headache.
Well, Declan Starr, it's been fascinating talking to you about occupancy sensing for the smart home. Thank you for listening to this podcast, this latest edition of Embedded Edge. My name is Nitin Dahad. Thank you very much.
Thank you, Nitin, for having me.